Dear colleagues, my name is Vladimir Smolin. I am from Keldysh Institute of Applied Mathematics, Moscow. I will be glad to tell you about the object state subspaces maps and why they are important for artificial general intelligence. One of the main problems of artificial intelligence is that the real world is very complex. But fortunately it consists of rather simple objects and phenomena. For example, cat we can just name or describe it by some vector, or this vector can change and form subspace of its states, and this subspace of these vector states can be mapped, so we can make the approximation of this subspace, and it will be the main object we will speak about. 10 years ago, a neural network revolution in machine learning took place. The main achievement of this revolution is that we can adjust millions, billions and trillions of parameters, and that it makes it possible to solve very complex tasks. Modern networks have excellent results in solving different problems, but it is known that if the complex is narrow, it will be solved perfectly, but for wide problems, modern neural networks, even very deep, have some problems. So in July of this year, Benjo, LeCun and Hinton next time spoke about these problems, and one of the main problems is the problem of scaling the results of these networks. And object state subspace maps is a way to solve many problems, and I'll try to describe how it can be made. What is approximation by mapping? So, for example, ball on the surface we can see in different positions, and because the position have only two coordinates, we can describe it by two-dimensional space. If we have different tasks to work with this ball, the dimension of this space will be larger, but still it won't be tens or hundreds dimensions. It will just a few dimensions will describe this space. Also, for each point of this space we can coordinate some knowledge and action, so understanding what to do with this ball. The mapping of simple object is rather simple, but the problem is that the world is complex, and this consists of different simple objects, and we should make decomposition of this world before mapping simple objects. This decomposition may be one or several steps, but it is one of the main problems. So the mapping of the simple object subspaces is rather simple task, but the problem is how to organize decomposition of signals from this object, from complex signal from real situation. Each neuron can be thought as a memory cell, so his input vector just associative k, which allows us to find out when to switch this element on, and then to play back the information written in the output vector. And if we want to continually change output information, we should move from one neuron to another, and when they by turn will be switching on and off, we can read the information written on the output vectors and to reproduce it. knowledge and understanding is different sides of information. So we can show that we have not only knowledge but understanding if we can build a model of some process. We can create a very large variety of different models and devices which worked perfectly, but these devices only show that we understand in the process that they are performing. But these devices are understanding nothing because they are not building models and can't understand what they are doing. And if the model will be able to create models, we can think that it will be able to understand something. So these models shouldn't be abstract. They should correspond to real objects and phenomena, and our model able to build models should be also able to develop rules of controlling these objects. And then we can think that this device can understand something. And objects, state, subspaces, maps is just the way of creating such models. Modern neural networks are capable for creating models, but these models can solve only narrow tasks. Why is it so? Because there are some problems with approximation and decomposition of tasks they are solving. So in these questions, neural networks are not perfect. Approximation can be improved by using simple objects maps. Now we use for approximation backpropagation error algorithm, and this algorithm allows us to record the output signal, but it's also sufficient for us to record the input signal, and mapping can do it. Also, mapping solves the problem of spreading the input vectors over the subspace X, where the vector describing simple objects is shown. Also, modern neural networks can make some decomposition. Convolution is for sure some way of decomposition and is structural. And in fully connected layers, the decomposition is not so obvious, but for solving problems it will be good for optimization, and if some decomposition occurs, the solver of problem will be better. So we can suppose that if we have many layers, the probability of decomposition is in many layers will be higher. But still, this decomposition is probable, and object subspace maps is the way to make it deterministic, and it's the next step in the process of decomposition. The main decomposition idea is just that we have the real input and the model of this input. If they differ each other, the difference is what we can model properly. So it's just this picture is just to outline this idea, because for sure it won't be so that here is no bet, but if we don't have a good model of bet, so the difference in this place will be larger than in other image, and we can improve our model. Also, we will work not with images but with activity vectors, because there is no gnomes for whom to show these images, and except object subspaces maps, we should have some screens where we can compare the real input and the model we created to outline what we should improve. Generative adversarial networks is modern networks that some way realize this idea. There are different schemes showing how this nets works, but the main idea that they are trying to approximate the latent distribution, and so this is just some model of subspace of vector activity in hidden layers. And if we have the good model of this latent subspace, then we can solve a lot of interesting tasks. For example, we can see in the internet the site which face is real, and you can play by choosing what of these two faces is real. Here with the green line is outlined what faces are real, and on the first view it seems that both faces are very good, and it is difficult to determine what face was real and what not. But if you click on this site and try 10 or 15 times to find out what face is real, then it will be rather simple for you to find what face is real, because you easily find some details showing that this face is not real and this is quite real. Also, there are a lot of solved tasks with using GANs and other network models, so only we could make some decomposition of the image, so we can see the phone, the man and his luggage, and this is for sure some way of decomposition, and modern networks are rather good at this question, but it's good for narrow tasks, unfortunately. So we should think how to improve this decomposition process. And as I mentioned previously, decomposition process by simple object subspaces maps is the way to improve the decomposition. And so for make this process of decomposition and writing the maps of subspace of object subspace, we need to have the hardware, so the structure where we can do this record. This structure not only should exist before, but there are some problems of concurrent activity solved and some other, and they should work properly. So when we use this device, it should not surprise us that no neuron or no trigger is very smart. They are all are not smart at all. They just the devices to record and play back some information, and they worked with activity of lower and higher levels, and just record and reproduce the information they recorded before, and this helps to make model of the world which we can see or hear or touch and so on. The process of recording is rather complex because we should make the model of simple objects, and the signal can be very complex, so just be a sum of a lot of simple objects. To do this, we should have the device which these models are already existing as a hardware and have some initial information, have nothing common to the information coming from the real world, but still some these maps have better coordination with input signal, and some will have worse coordination with input signals. So it allows us to choose which maps more similar to input signals and which maps not correspond to input signal. And those who corresponds better, we can write this new information so they will correspond perfectly. So this process should be divided into concurrent activity process. So we should choose between maps which correspond better, and in each maps that have good correspondence to input signal, we should choose the element which corresponds better to the current state of this object. So playback is rather easier, but still to make this playback good, we also should divide the input signal into parts and reproduce information from each map of simple object corresponding to the states of this object. And why this signal goes through the map, or maybe very complex trajectory. Along this trajectory, the output information, which was recorded in output connections, can be reproduced and used for control, for understanding how good our knowledge about this object, and improving this map. Also, we not only can use this process of recording and playback just for getting the information from the real world. We can make a simulation of some situation which we never saw before. If the task is rather easy and the lower layers can perform this task correctly, then the higher layers are free for some time while this goal isn't reached, so they can be used for modeling different situations and to choose the better behavior to achieve the next goals, and just to choose these next goals. And these two ways of using these simple object states maps is just an analog or to Daniel Kahneman system 1 or 2. So if we just play back the information written in these maps, it is system 1, and if we before reproducing this information perform some simulation process, this is analog of system 2. To make optimization of behavior, we need some criteria to comparing different variants of this behavior. We have feelings to optimize our behavior, and also our devices can have some analogs of feeling, because the process of recording and reproducing and also some other parameters, they are not only good and bad, so there are a lot of parameters, and we may change them differently according to the situation, and it's not so difficult to make AGI agents with a set of lower level feelings aimed to maintaining performance, providing energy, seeking new information, and making them friendly to us. It seems a very difficult task, but we have some experience. For example, with dogs, we have no idea 1,000 years ago how the brain works, but still we could select useful and friendly dog breeds. And now we understand something about neural networks, so we have more opportunities to make good feelings for our AI agents. Also, not only the feelings are controlling our behavior. Attention and consciousness is properties that helps us to coordinate these two regimes of working these object subspace maps for control of situation and for modeling the situation we can assume. And this process can be additional function of the screens, so these screens have enough information to control is the process of behavior is performing good, or we should change the goal that was extension, and so on. And these problems is very similar to the conscious. The process of stating the goals or choosing the goals is in many reasons equivalent to optimization process. So when choosing our behavior, we are thinking how to make it better, and the choosing of goals is aimed to the same direction. So we can choose global and local goals for playback and recording in neural networks, just thinking of optimization of this process. And also it's just a routine result of action of optimization. We usually use standard goals, because for highly abstract concepts it's rather difficult task to choose good goals. That's why we're not always trying to choose these high-level goals ourselves, but use somebody experience in this area. One of the main result of this consideration is that the knowledge is the base of the understanding. Although we have, for understanding, to build simple continuous models of real objects, we also for this process should possess some knowledge, because if we are seeing a complex situation or object, for understanding it we should understand the work of all its parts, or maybe the majority of its parts. Other way, we won't be able to understand some complex problems. So the knowledge of which was accumulated by our civilization is the base for the progress in this area. Also, there are 5 degrees of difficulty in explanation of our world, and I outlined 5 steps of this difficulty, and the main is just the complexity of setting needs. All of them seem solvable if to use these objects, states, subspaces, maps. And on the definition, what is object, states, subspaces, maps, it's rather more convenient to explain what is artificial general intelligence. I would like to agree with Tegmark that it's something like Life 3.0, which is capable not only for survive and replicating and design of its software, but also for the design of its hardware. So if we can build models that can model the outer world, these models would be able to build themselves and will become the Life 3.0. Also, we can develop our medicine and make some keyboards, and it will be the other way to Life 3.0, but still we are quite near to solving this question. And the other point of view to this question, that somebody thinks that artificial general intelligence will solve any problem. It is not so. So also the progress will be great, but as now we can't solve just creating Life 3.0 and, for example, some other science or technological question, also some problems will be left after the creating Life 3.0. Here I discuss some definitions of conscience level. So I try to show that animals are smart enough, the higher animals, but the man is smarter not because his body or brain differs a grade from them, but because he can build manage to build civilization and use knowledge, and it makes his mind stronger, makes his intellect, and civilization helps to develop this intellect. And to make a conclusion, I'm trying to tell that we should approve approximation and decomposition first, because it's one of there are the main problems to develop our artificial general intelligence, because without solving this question we won't be able to build models that can create models themselves. And if we solve this question, we will be able to bridge the gap between the deep neural networks activity and the higher level representation, such as understanding, thinking, and consciousness. Also, I will be happy to discuss the RAID issues in more detail, so here is my email and you are welcome. Thank you for your attention. My name is Vladimir Smolin, and here is my email for contacts. Goodbye.